So let's take a look at this sample free response question from the AP test. It's actually not a sample, it's an actual test. We're calling this number 095B, and we are given the graph of the derivative of the function f. And then we're told that f is a twice differentiable function defined on the interval from negative 1.2 to positive 3.2. That's an open interval. And we're told that f of 1 equals 2. The graph of f prime, which is the derivative of f, is shown. The graph crosses the x-axis at x equals negative 1 and x equals 3. Now, right away, that tells me that I've got critical points for the function f at those two places because the derivative is 0. F prime has a horizontal tangent at x equals 2. That's good to know. And g is the function defined by g of x equals e to the f of x. So f of x is the exponent there. All right, let's see what they want us to do here. I'm going to start with letter A on this slide. So letter A, this is 095B, letter A says write an equation for the line tangent to the graph of g at x equals 1. Now that line is going to have the form y minus g of 1 equals some slope m times x minus 1. And the way we get m is g prime of 1. So those are the things that we have to accomplish. Okay, so in order to get g prime of 1, I have to take the derivative of g. Let's start with that. We know that g of x equals e to the f of x. And so the derivative is going to be, this is like e to the u, so the derivative would be e to the u times u prime. So that's going to be e to the f of x times f prime of x. And we need to compute g prime of 1. So we're going to plug a 1 into this function. So we're going to do e to the f of 1 times f prime of 1. Okay, that's how we're going to compute this. And let's see, they told me that f of 1 is 2, so this part is e squared. And f prime of 1 is, what is that, negative 4? So my slope is negative 4 e squared. Do I know what g of 1 is? G of 1 is e to the f of 1, and we know that e, so that's also, let's just make a little note here. G of 1, because I need to know that, g of 1 is e squared, because e to the f of 1 is e squared. Okay, so I'm ready to write the equation for this thing. We have y minus e squared equals negative 4e squared times x minus 1. There's our equation. If you want to clean it up, you can, right? You can distribute and then move that y minus e squared, move the minus e squared over to the other side, but didn't say we had to do that, so I'm going to stop with the equation in this form. And that's the answer for letter A. Okay. Not bad. We'll do letter B on the next slide. So let's move on to letter B, like I mentioned. That would be this one right here. For the interval from negative 1.2 to 3.2, find all values of x at which g has a local maximum. Okay? So we're looking at the function g, and we need to find our local maximums. Typically, we do that with the first derivative test. So let's remind ourselves what the derivative of g was. We said that g prime is e to the f of x times f prime of x. It's a little chain rule action there. And we're looking for critical points, so we need to know where this thing is either equal to 0 or undefined. So where does this equal 0, and where is it undefined? Okay. So you'll notice here, if you look at this function, that e to the f of x, right, is always going to be positive, so that the only time g prime will equal 0 is when f prime of x is 0. So we really just need to find out when f prime of x equals 0, and we already know that. They told us that that happened at -1 and at 3. So those are our critical points. So let's make a sine diagram and see what happens. Remember, we're making a sine diagram on g of x. Let me just remind you. Excuse me, g prime of x. So here's the sine diagram on g prime. Okay. So since e to the f of x is always positive, the signs of our derivative are going to be the same as the signs of f prime. So you'll notice that over here, f prime is positive. So that function is increasing. It's 0 at -1. It's negative in here. So that's decreasing. And then back over here, it's positive again. So we have a min right here. Not that we're worried about it, but more importantly, we have a local max right here, right? Because g prime changes from positive to negative. So because of that, we know that g of x has a local max at x equals -1. All right, and that's it for that one. It's not a straightforward first derivative test because we have to really just pay attention to f prime of x. Since e to the f of x is always positive, it really helps if you know your parent functions, and the exponential function is always above the y-axis, or the x-axis, excuse me. Okay, so for this one, the local max is at x equals -1. We'll take a look at letter C on the next slide. So in letter C, they're actually going to have us take a look at the second derivative of g, which is g double prime. And they've went ahead and done the product rule for us and factored it. So the second derivative, and you can go through this math if you want, it's not that difficult. But after you go through the product rule and then factor the second derivative, the second derivative, you get e to the f of x times the first derivative squared. And actually, I like to just write that like this. So let's go ahead and write this down. G double prime, it's going to be e to the f of x times the first derivative squared, which is essentially the first derivative times the first derivative, plus the second derivative of f. They're asking the question, is g double prime of -1 positive, negative, or 0? So we're going to have to do some calculations here. All right, so I need to know what e to the f of x is. And let's talk about what x is going to be here first. X is -1. Oops, wrong pen. X equals jeez. I'm having a good go here. That's -1. So that means we really want to know what g double prime of -1 is. Or at least the sign, right? Positive, negative, or 0. Okay, so we need to investigate what e to the f of -1 is. And we just talked about how that function's positive, right? The exponential function's positive. So this thing right here, I'm going to put a big plus sign underneath that, because whatever it is, it's positive. Okay, now let's figure out f prime of -1 times f prime of -1. Well, here's f prime, right? And f prime of -1 is 0. So that part is just 0 times 0, which is just 0. And then we've got a plus sign. And we need to look at the second derivative of f, which would be the slope on this graph, right? And the slope at -1 is negative. So this is 0 plus some negative number. So this thing's negative, right? This whole thing here is negative. So we have a positive times a negative, which is negative. And so I'm going to answer that g double prime of -1 is negative. And it's just really analyzing the signs of the different pieces of the second derivative. E raised to some value is going to be positive. E raised to f of -1 is positive. It's some real number. We don't know what it is, but we know it's positive. And then the first derivative at -1 is 0. We get that right off the graph, so we got a couple of those. And then we get the slope off the graph. We know it's negative. We don't know the value, but as long as it's negative, we know that whole thing is going to be negative. So that's it for letter C, and we'll finish this thing off with letter D on the next slide. Okay, so we're almost done with this whole problem. Item D here is to find the average rate of change of G prime, which of course is the derivative of G, on the interval, closed interval, 1, 3. Just to remind you, the way we do the average rate of change is going to be G prime of 3 minus G prime of 1 divided by 3 minus 1. In other words, we're going to divide by 2 there. But that's how you do the average rate of change, y2 minus y1 over x2 minus x1. So let's get organized and get some values down here. Remember that g, the function g, let's just highlight that thing again, is e to the f of x. So I'm going to need to know some f values. We were given some f values. We were given f of 1 is 2. Were we given any other f values? No, I don't think we were. So let's see if we can figure this out. So that's g, but remember we need to know what g prime is. So let's write down g prime of x again. G prime was e to the f of x times f prime of x. So when we compute g of prime of 3, we're going to have to compute e to the f of 3 times f prime of 3. And when we compute g prime of -1, we're going to have to do e to the f, not -1, g prime of 1, e to the f of 1 times f prime of 1. So let's just get some of these values down here. Essentially what I need to know is, I need to know what f of 1 is, and I do know that, that's 2. And I need to know f prime of 1, and I do know that, that's on the graph right here, that's -4. So that's good to know. All right. So that means g prime of 1 is going to be e squared times -4. So that's good to know. So, oops. As I fill in these spots here, this g prime of 1 is going to be e squared times -4, better known as -4e squared. Okay. I'm also going to need to know f of 3, and right now I don't really have any way of knowing f of 3. I'm going to put a little question mark there. But I do know f prime of 3. It's on the graph, right? It's right here. F prime of 3 is 0. Ooh, that's great news, because that means I'm going to do e to the question mark times 0, which is 0. So this piece is just 0. Whew. All right, good. That means on top I just have 4e squared. And remember, 3 minus 1 is 2, so this is just 4e squared over 2, better known as 2e squared. And we're not in the calculator section, so there's not like I can compute that or anything. I'm just writing it down and getting the heck out of here. I'm done. Okay, just once again to show you what I did here. I have to, each time I do g prime of x, I have to plug in e to the f of x times f prime of x. So e to the f of 1 would be e squared times f prime of 1, which is -4. That's how I got this part right here. The real issue was I don't know what f of 3 is. All right, that's some weird question mark. But I do know that f prime of 3 is 0. So that's going to be e to the question mark times 0, which is just 0. And that saves me. And from there, it's just a matter of simplifying, which we did. We get 2e squared. And we're done with this free response problem. So hopefully this helps. As you're working on these practice free response problems, please be patient with yourself. There's a lot of math put together in each of these problems, a lot of calculus, and it takes practice to get used to drawing from all the concepts that we've covered over the year. So we're going to be patient. We're going to work together on this, and we will succeed. Take care.